Hi, everyone. Thank you for joining us today. My name is Sakshi Sethi. I'm with OSA's Corporate Membership Program, also known as OIDA. I'm excited to introduce today's webinar. It's sponsored by one of our corporate members, Optiwave. But before we get started, I just want to take a minute to review a couple of housekeeping items. So if you need any assistance on today's webinar program, please use the chat icon. It's located at the bottom of your screen. You can use this to get in touch with me directly. I'd be happy to answer any of your technical questions. If you're having trouble receiving the audio or the video, I can certainly try to help with that. During this webinar, though, we do encourage you ask our speakers some questions. It's definitely meant to be an engaging conversation. We hope that you find value from this program. And if there are any questions, this is a great opportunity for you to be able to ask them directly. So also at the bottom of your screen, you'll see a Q&A icon. Please be sure to type in your questions directly here. Again, the chat icon is used to message me. Any technical issues, the Q&A is for the speakers. That's where they're going to be looking to answer your questions. As a kind of final reminder, this webinar is being recorded. The video for this webinar will be posted on our website probably early next week, hopefully by Monday. I'll drop a link in the chat box in just a moment as to where you can find that recording. Each of you will also receive an email on Monday with that same link as well. I also, just kind of a final thing, it's not up on the screen, but once you log out of this webinar, you will receive a very, very brief post-webinar survey just to see how the program was, how the speakers were, any thoughts, comments, and feedback. I do encourage you to just take 30 seconds or so of your time to just complete that and fill that out. But without further ado, I'll go ahead and turn things over to our main speaker, Ahmed Atiye, to get us started.
Thanks, Sakshi, and hello, everyone. Let me share the screen here. Okay. Yeah, I'm trying to go. Okay, here you go. Okay, so today webinar would be about OptiInstrument software, which is a new software introduced about a year ago to control and communicate with equipment and set up these equipments and enable data collection and operation of these equipments. Today, I will be joined by my colleague, JD Brambat, who's going to do the demo for OptiInstrument software. Okay. The Optiwave, just general information about it. We have Optiwave established in 1994, and it's located in Ottawa, Ontario, Canada. Optiwave developed different types of software, which used for designing, simulation, optimization of components, links, systems, and networks. The simulation tool enables users to be able to design their systems and shorten the introduction, as well as improve product quality and enhancing the productivity and cost effectiveness through this kind of simulations. Optiwave softwares, different types of softwares, has been licensed in over than 80 countries in the world, and over than 1,000 industry corporates, universities, research, and governmental institutions. Optiwave main product is categorized into 3 categories. As you see here, the first one is the system level product, which includes 2 types of software. One of them is OptiSystem, which is a communication kind of software used for link and designs, and then OptiSpice, which is an optoelectronics software. The second category is the component level software, which includes different software packages. As you can see here, the BPM software, OptiFDDT, OptiFiber, and OptiGrading. And the last category here is the OptiInstrument software, which is mainly used for communication and control of instruments. And this is today's webinar would be about this software. Now, any user can download a 30 days evaluation of any software of Optiwave. You have to go to Optiwave web page and then go under downloads and then click on the 30 days evaluation. then this pop-up window comes up to register yourself and create a password. Once you create a password, you'll be access to all the software and download whatever software you'd like to have. Once you download the software is going to be saved under program files, Optiwave software, and then the software package which you download. As you can see here, the download of OptiInstrument, when it goes to program files, you're going to have two major directories here, the bin directory and the document directory. And in the bin directory, you're going to have the executable file as the drivers, as well as the drivers. And in the documentation folder, you're going to have the documentation, which is three major documents here, PDFs of getting started, new release, features, and release notes. In this slide here, just to show you the kind of concept of OptiInstrument software, is you have your own equipment, which you may connect through, let's say, USB cable, GPIB cable, or serial cable like RS-232 or RS-485, to a laptop or a PC where you have the OptiInstrument software installed on it, or you have this software is like somewhere remote, and you can communicate with this equipment through the internet, through TCP/IP connections. The general view of the GUI of OptiInstrument software, as you can see here, there is different windows, and each one of these windows is going to be accessed like this is a main window. You can have different functionalities which you can access them. I'm going to talk about all these details in the demo. Now, there is another window here, as you can see, for grid and graphs where you capture the data and you can get the data. You can have also processing of the data. This is the window where you execute the commands as a sequence, or this window you can execute the commands as a single command. So there is all of these details. We're going to speak about them in the demo in more details. The main message of OptiInstrument software is OptiInstrument software is able to communicate with any equipment as long as it has support SCPI commands in it. So doesn't matter it is optical or electrical or whatever the equipment is, as long as it has the SCPI commands, you should be able to communicate with it through OptiInstrument software. In this part here, I'm going to speak about the major features of OptiInstrument, which is being developed through the different versions. Currently, we have version 2.1 version, which is, again, as I said, the first version was released a year ago in July 2020. And these features has been updated during the process, and we are still working on new features now for release 2.2 expected in a couple of months. Okay, so the first feature here is as I mentioned, OptiInstrument software can be working with the equipment if it is co-located or remotely placed. OptiInstrument also can execute single command of SCPI commands, or can execute sequence of commands. Now, in the sequence of commands, you can have the control to do different functionalities of testing or setting parameters and querying data and collecting data, and having some kind of logic control where you can enable all of this kind of testing in your code. Now, it allows the also loading of a SCPI command as a file. So these SCPI commands can be saved as an XML file, and this file can be loaded and can be shared and can be transferred from location to location. So this is a process where you'll be able to load these SCPI command sequences. Also, the OptiInstrument software allows the users to load other types of documents like PDFs, PowerPoints, documents, Excel sheets in a specific window. And users can, once they save the project, the window, as I'm going to show you later, these documents will be saved there and can be accessed and shared for future applications. The OptiInstrument software also allows the user to have a flexible sequence ordering. So once you write the commands, for example, the process can be either you load the XML file, or you can test command by command and then add it up to the sequence. And these commands can be arranged like up and down, and there is a flexibility in the process. Also, OptiInstrument software allow Python script creation for either the single command or the sequence commands. Now, once you create this Python, this Python can be script can be executed from either the GUI itself or externally from, let's say, a Windows PowerShell or a command prompt. Now, OptiInstrument also has a Windows-specific usage for Python script editor. So you have all the functionality which you need to run Python in that window. So you can edit and you can do all of this. Even once you create this Python script, you can edit it. You can add up commands to it as needed. The software GUI allows some of these windows to be dockable. So you can move them around, you can place them in different positions, and you can also resize them. So this is the flexibility of the GUI. The GUI OptiInstrument allow the users to set all command sleep time or independent sleep time for commands. Now, this to accommodate different equipment testing, because some equipments, when you execute a command, sometimes it takes longer time. Sometimes the equipment, once it responds, it takes some time. So this can be adjusted in the software. The software also have a window specifically for output, where all this sequence of commands, when they are executed, is going to see the output displayed on this window. And then this window can be, the results of these outputs can be saved as a JSON file format. And also this output, once you save it in a JSON file format, you are able to post-process them. So you can select certain data and you can plot them in 2D graph, a single plot or multi-plot 2D graphs, as well as 3D plots. Now, the process data, once you create it, the process data, you can save it as a text file or a CSV file format. So lots of, as I mentioned here, the features which are being developed through the different versions of OptiInstrument. Now, the OptiInstrument software also has a signal viewer, as I showed you earlier. We're going to show you more details later on as well, where you have the grid and the viewer, and then you can display the captured signal, which is a single plot or multi-plot captured data. Also, you have a UI inside the viewer where you are able to, or the display window, to able to change the units. So once you capture the data in the grid, let's say, for example, the unit of power in dBm, you can change it into any other unit you want, milliwatt. Same thing, for example, if you capture the voltage and in volt, you want to make it millivolt. If you have the time axis in seconds, you can change it to any unit, millisecond, and so on. Frequency in hertz, you can change it to nanometers and so on. So lots of flexibility in the capture of the data, as well as you can change the titles and labels of the display graph. So once also the graph, you are able to capture single graph or multi-graphs, and then you can download these graphs and save the plot itself as an image. The software has the logic control commands where you can use a while command, for command, if, else if, and else. There is a helper commands which you can use through the sequence of command codes which you write to enable intelligent and sophisticated control of the equipment. So you can have sleep command, which you can do it per command. You can have break, continue, print, as well as, let's, for example, variable. You can set it up to certain values and then use it in the code of the sequence of SCPI commands. Now, the software also allows you to use alias names for the equipment. So you can rename the equipments based on your desires. And also you can replace the resource information. So for example, if you create an XML file with certain resource information, let's say a TCP/IP address or something, you can change it. Let's say this example on the fly, automatically through some UI added up to the GUI, where you can change the resource name and then use that specific actual resource name in this execution of the command. The software also have error messages where it tells you the type of error when in the sequence of command when you execute it, and the location of that error. Okay, now I'm gonna go through the applications which you can use OptiInstruments for. First one is, as I said, is communicating with control of instruments. So you can set up parameters and you can run the equipment and then collect data and collect also displays of these data images. You can automate testing and characterization. This is very good application where you, for example, you have long-term testing where you want to do stability or you want to do testing under certain conditions. So you can use the logic commands as well as the helper commands to create a sequence codes where you do this kind of long-term testing. There is examples on OptiInstrument software where you have some of this functionality being implemented using the equipment from different vendors. Now, as I mentioned, also it captures display multi-signals. You can extract and save the data, and for post-processing in a text file or a CSV file, save captured multi-graphs, and these graphs you can save them as bitmaps or EMF, or you can copy it to clipboard where you can save them as JPEG or GIF file or TIFF file or PNG. So you have lots of flexibility there. You can also integrate OptiInstrument with other photonic and system simulation tools. So you can run the equipment and then you can capture the data, and the data you can load it into another software where you can use it as for the simulation, let's say in the system simulation. In this part here, I'm going to talk about the saving process of OptiInstrument files. So for example, you create your sequence, you have a sequence here, and then you, let's say, create whatever the process. And then eventually what you need to do, you need to save the file. As you can see here, the default name at the top of the screen is a default name, which is whenever you start the software, you're going to have it. But once you start to save using the file and then save a feature save as, you can use a certain name, for example, for the file. Once you save that name, then eventually you can see the file name at the top. And this file name, once you, let's say, for example, use the open to load whatever you save in sequence or documents or the whole process which you created. Okay, now I'm going to give some more information about the Python scripting capability of OptiInstrument. And as I mentioned, the OptiInstrument allows creating of a script for a single command or a list of commands. It depends on the where you check the Python script edit creation. Now, this Python script creation, you can right away it appears in the editor. So this is a specific window, as I mentioned, for Python script, and that generated script will be appearing there. You can edit that one. You can run that script from a GUI, OptiInstrument GUI itself, or you can save it and then load it into and run it from the command prompt or Windows PowerShell. Now, Python script can be loaded into OptiInstrument GUI and executed as I mentioned, in the GUI itself. Okay. So in this part here, I'm going to talk about the UI, which is used to capture multi-waveforms, as you can see here. So once the icon, as my colleague JD is going to show you the demo, the icon which used for capturing the waveforms and the process how to use it. But once you click on it, this pop-up window or UI is going to appear, and then you select the equipment which you wanted to capture the data from it. And then once you select that, you can select how many channels you need to display, single channel or multi-channels. And once you select which channel you want to capture, then you say generate the waveform. The waveform is going to be created in a grid as a data and a display here in the plot. You can save the display from the icon here, You can also, as I mentioned, you can change the units, you can change the labels, and so on in this process. One important resource of OptiInstrument is the example library, which also once you download the software, you can have access to it. In the library, we add up examples from different vendors. Right now, we add up examples from Expo using the LTP8. We use different cards in this platform, and also we use the Regal function generator and oscilloscope to do some examples and demonstrations. So the example list here, as you can see, in Expo we use card, which is a PowerBlazer card. We did some experiments using the SCFB for transceiver. We have also the OTT card. We did examples on it. You can have access to these examples in the example library. So once, if you have the platform, you have the card, you can just only load the XML file and then run. The only thing which you need to worry about is, as I mentioned earlier, is the resource name, which you can also change it, because every computer or every PC has different TCP/IP, or if you, for example, USB connection or something different, then you have to choose that. And as you can see here, there's different cards of our meter, switch, VOA, CW sources, and so on. So lots of examples in here. And the Regal examples also we have on generating different waveforms and capture them in the GUI. Okay, so now I'm going to move into the demo. The demo would be using the LTP8 Expo LTP8 equipment, and we're going to demonstrate examples for running CW lasers with the switch and OSA card to capture the spectrum, then the wave of the lasers, as well as we have OTDR example to run. So I'm going to move into the audio here, and then this recording is done by my colleague JD.
In this webinar, I'll be demonstrating some of the new features that we have added to OptiInstrument 2.1, and then I'll also be showing you two sequences which will highlight some of the new features of OptiInstrument 2.1 and also the capability of 2.1. So let me first go ahead and quickly go over the GUI of OptiInstrument. So on the left here, we have some of the useful tabs. And one of the first tabs is Instruments tab. Here is where you can connect to the instrument, and the connected instruments will show up in a list here. And once you connect to them, you can set up an alias. And once you have assigned your alias, you can also save them to registry, which will make it so that every time that you connect to the instrument, you don't have to set it up again. So that's the Instruments tab. Then we have the List of Command Sequence tab. This is where you will see the sequences that you import in a list. So you can have multiple sequences here. And one of the new features that we've added in OptiInstrument 2.1 is a replace resource names. This feature will allow a user to basically change the resource name of a existing sequence. So for example, you have a sequence here that you want to execute on a same type of instrument with a different resource name, or let's say if you have multiple instruments of the same kind but with a different resource name and you want to test the same sequence on them. So rather than creating a new sequence for each instrument, what you can do is replace the resource name in the sequence, and this will allow you to execute the sequence on instruments with different resource names. So to replace the resource name, you would basically pull up this tool by clicking this button here on top of the List of Command Sequence tab. And here we have the current resource name, then we have its assigned alias, and then we have the column with available resource names. And when you click on the instrument resource name, here it will show you all of the available instruments that you have currently connected to OptiInstrument. And you can simply select the resource name that you want to change of the instrument, and you can select that and just simply click on the replace box here on the left and then press OK. By doing that, it will replace the resource name in the sequence, and now you can go ahead and execute the sequence. So that's one of the new features that we've added. Then the next tab we have is the SCPI commands tab. Here is where you will see some of the common commands that are used or rather available in most GPIB instruments. And you can also import command trees for supported instruments, which are provided in the sample library. Then we have the documents tab. Here you can import PDF documents, and then you can open them through OptiInstrument. Then we have the Python script tab. Here you will have your Python script, which will show up when you create a Python script out of a sequence or just a single SCPI command. And once you have your script here, you can edit it, and then you can run it within this tab. Then we have the logic controls tab. This tab has control blocks, which will help you create much more complex sequences. And then we have the basic helpers, where you can add sleep time and print statements and create variables, and all of those basic helpers are in this tab. So those are the tabs. And then moving on to the single SCPI command window. So here is where you can execute a single commands. You can send to the instrument, test them out to make sure they're working. You can select the instrument that you want to send it to. You can create a Python script out of it as well. And then we have the settings tab, where you can set your instrument parameters. So in this case, we have a TCP/IP instrument connection. So we have a TCP/IP settings, but let's say, for example, you had a USB or a GPIB connection, then these setting parameters will change accordingly. So depending on the type of connection, it will have different settings. Then we have the command sequence window. This is where you will have your sequence, and you can create your sequence here. You can modify it. You can create a script out of it. You can execute it from here as well. And then we have the output tab here. This is where you will have your output from the executed sequence. And depending on the type of sequence that you've executed, you'll see all your outputs here. And then the last window we have is a display window. This is where when you capture a waveform from an oscilloscope or optical spectrum analyzer, they will show up here. And then the data points of the captured waveform will show up in this grid tab. So that was the GUI. Now let me go ahead and show you the setup of the first sequence that I'll be showing. So the first sequence involves two laser sources, which are connected to an optical switch. And then the optical switch is connected to the optical spectrum analyzer. So it's a simple sequence which will demonstrate how to capture an OSA signal. So let me first go ahead and run the sequence by pressing the run button here. So once I run it, a command window opens up, and here you'll see the progress of the SCPI execution. So it's done executing. And when I go to the output tab here in the command window, I can see all of the outputs. So we have a 1310 laser source that we did some measurements on. So we have the central wavelength, we have peak power, and then the second source we had was 1490. And then we have the wavelength and peak power and frequency. So now if you wanted to capture the second signal, which is the 1490, you would simply go here and select the instrument. So in this case, it's X4 LTV8, and then click on the display waveform button, which is at the top. This will initiate the capture, and now you can see the signal shown here in the display window. And if I switch to the grid, you can see the grid where you will see your X values and Y values. So another new feature that we've added is you can change the units, and you can also name these columns on the data. So to do that, you would just click on the upgrade grid button here at the top, and this little grid updater tool will open up. Here you can choose which column you want to change the name or units to. So for example, let's change a column A. Currently it's in the wavelength, so let's just first name the column. So I'll just name it wavelength, and then go to the units. In this case, it's just nanometers, and the desired is also nanometers, just to update the column. So when I press OK, it will update. So now it's updated to wavelength. Now let's go ahead and update the second column. So here, the second column is the intensity values. So I'll just name it intensity, and then go to power unit type, and in this case in log scale, so it's in dBm, and also the desired value is also dBm, and then click update, and it's updated the name. So now let's go ahead and change the units of the wavelength column to frequency. So if I go ahead and select column A, and then name the column to frequency, and then go to the frequency unit type, and currently it's in nanometers, and I want to change it to terahertz. So I simply select that and then update, and as you can see, it updated the values. And in this case, it's the entire column of values which have been updated. And if I now go back to the waveform, you can see that it's also updated the grid, or rather the x-axis to frequency terahertz, and it's also changed how the curve or the waveform is positioned. Now, if I just go back and change it back to wavelength, and go and change it from terahertz to nanometers, and then update, it's updated the values here, and then it's also updated my waveform. So that is the new really neat feature that we've added, which is the grid updater. As you can see, when you update your column of values to different unit, it also updates the waveform. So that was the first command sequence showing you the feature of capturing waveforms from an OSA, and then also updating or rather converting units, and also changing columns, column names. Now, after you've done your data manipulation or whichever unit that you've changed it to, you can export the same data into a CSV file format. So that is also available. And just to go back here to the output, this output, which is a raw output of the SCPI commands, that can also be saved into a text file. So that can also be done. So now let me go ahead and show you a second example that I have, which is an OTDR example. So we have an OTDR card, and which is connected to a fiber spool using a small fiber cable, which has a UPC-SC connectors on both ends, and the fiber pool is 10 kilometers. So this is the setup we have. Let me go ahead and pull up the sequence. So if I just go ahead and open the sequence, so we have the sequence here. And this sequence also has a for loop where the sequence is executed. So you can always change how many times we want the for loop to execute. But in this case, just to demonstrate the capability, we've only done it once. So let me just go ahead and execute the sequence. So as you can see, it is showing me the parameters that we have set, the wavelength of the laser source, pulse width, and the range, and the duration of the test. So once, in this case, the test goes for 45 seconds, so it'll take a little while for the test to finish. So once that finishes, I'll show how you can do post-processing on the results that you get from a sequence, and how you can plot those results using a post-processing GUI that we have also created. So the sequence is done executing, and here you can see the output. Again, you can save the output from this output tab as well, but let's say you wanted to do some kind of post-processing, you can do that by clicking the post-processing GUI button here. And once you do that, this GUI will open up. So here is where you have all of your outputs, and you can plot these values, you can extract them. So if you wanted to export it to a text file or a CSV file, you can do that simply just by clicking and then exporting it to a text file like this. or you can do it to a CSV file like this. It will organize it into a column of values. And you can also plot these values as well into a 2D graph and also a 3D graph. So this was the post-processing GUI. And so those are some of the new features that we have added into OptiInstrument 2.1. And that's the end of the demo.
Okay, so let me continue here. Thanks. Okay, so next here.
In this webinar, I'll be demonstrating some of the new features.
Okay. So what we have here, we're gonna just talk about the general message which we hope to convey out of this webinar. The first message is, as I mentioned earlier, is OptiInstrument software is capable to communicate and control any instrument which supports SCPI commands. So this is the first message. And second message, which is we'd like to open the door for any vendor of manufacturer of equipment manufacturer to coordinate with us, and if they wanted to include their instruments into the example library of the OptiInstrument. So we are open to any kind of collaboration with equipment manufacturers who are in that field, interested in this collaboration. With this, I conclude the presentation, and we are open now for questions. Thank you for listening. So let's see here.
So yeah, Ahmed, I'm going to read out a question. So there was a first question, which was not relating to OptiInstrument, so I'm going to leave that for now. And so there's a question from Zachary Hook. So he's asking which instruments are currently supported by OptiInstrument.
So we did incorporate the X4 platform, so LTD8 with different cards, as I mentioned to you in the example library. Also Regal, we tested them. We tested Keysight, arbitrary wave generator, and oscilloscope as well. We didn't have, because we had limited time when we had the equipment in the lab, so we didn't have a chance to create the whole example library. But we are open for any vendor to try their equipment and create the sequence as well as an example in our example library. Thanks for the question. Next question, JD.
So next one is from German Ervalo. It's kind of relating to the other question. He's asking, does it work with Keysight equipment? I think you kind of answered that, but if you wanted to expand on it.
Sure. We tested as again arbitrary wave generator and the oscilloscope with Keysight, and we are open. We are still open again is to collaborate with any vendor. We had some recent discussions with Keysight to include more equipment, and we're gonna work on it and continue working on it. Thanks.
Thank you. So there's another question. So is it OptiInstrument, does it work with other kinds of connection protocols like GPIB and any other ones?
Yes, so you can do through Ethernet cable, GPIB, USB, serial RS-232 or RS-48. So, and in the market, there is lots of converters. So if you have, let's say, for example, you can convert from certain hardware to another hardware. So you can convert from GPIB to USB and so on. So that is possible as well.
Okay. Thank you. So another question, I was kind of answering it, but it's an interesting question, so I'm just going to throw it to you. Can a particular script sequence, instrument collection, etc., can become a standalone? For example, can I create a process for a purpose, save it, assemble the hardware, and sell it all as functional package without the entire suite? And a second part of the question, how do these suites offering compare to LabVIEW?
Okay, so in the first part of the question, yes, you can create your own sequence and then attach it, like to address that sequence for certain application or certain equipment, and you can, as I mentioned, you can exchange it as an XML file, so you can sell it with your equipment definitely, or your modules, if you want to call them. And then the users who buy the software will be able to load that XML file and then run it and execute that XML file. They need to change the alias name, as my colleague JD has showed you in the demo. That's the only thing. Now, the second part of the question is
how does it compare to LabVIEW?
LabVIEW. So compared to LabVIEW, I mean, the flexibility of OptiInstrument software is much more flexible than LabVIEW. So LabVIEW, first of all, you need the user to know has experience in programming and commands and so on. The OptiInstrument does not require any knowledge of the user to program. The commands, SCPI commands, is always at provided by the equipment of manufacturer of the equipment, where they describe the command. So what you need to do is if you have the document in a PDF file which you load to OptiInstrument, you can extract the information from there. Now, vendors, I know that they also provide the SCPI commands as a file, as we showed with Expo. So you can also load that and then extract the commands from there and then create your own sequence. So the knowledge of programming is not required in OptiInstrument compared to LabVIEW, and that's a big difference. Plus the flexibility, as we showed you, and the post processing and the capturing of the data and save them, units change. All of this flexibility is some advantage of OptiInstrument.
Okay, thank you. So another question. Is it possible to load the measured data into another of Optiwave's instrument? Software?
Yes, so at this moment, the current version up to 2.1, OptiInstrument is the data is you have to do it externally. Now, in 2.2, which is, I just mentioned, is in a couple of months is going to be available, you can extract the data and load it into another instrument, the Optiwave software, which is the first software we're going to incorporate OptiInstrument into it, would be OptiSystem. So there is a component created in OptiSystem, and you can call OptiInstrument software from that component, and then you communicate, you load your XML file, and then you communicate with the required equipment, and then set up the parameters and collect the data, and then take the data back to OptiSystem, and then use it in your simulation. So for example, you can capture arbitrary wave signals, you can capture, let's say, oscilloscope waveforms and all of these, and then you can use this data into the simulation for, let's say, for example, transmission over a fiber, or for sensor application, or whatever the application you wanted to do. So this is something which is coming in version 2.2 in a couple of months, yes.
Okay, so the next question is, I think I can answer this one. Can you operate OptiInstrument from Windows PowerShell using Python? So yeah, as Ahmed was mentioning as well, so you can create your sequence in OptiInstrument and then create a Python script out of it. So this Python script you can executed from outside of OptiInstrument or from from inside, as it was shown in the demo. So yeah, it can be operated outside of OptiInstrument as well, using a PowerShell or a command prompt. So next question, how many waveforms can be captured using the software?
So the new UI, which is added also to OptiInstrument, allows the user, depends on the equipment itself. So for example, if the equipment supports 2 channels, then you will be able to capture 2 waveforms. And then if the equipment supports 4 channels, you're going to be able to capture 4 waveforms. And the data of these waveforms is going to be in the grid. So you're going to have, let's say, 2 columns or 4 columns, depends on the equipment. And then eventually you can save the data. So there is no condition in OptiInstrument software about the number of channels as long as the number of channels of the equipment is already identified in this KB commands which you do.
Okay, so next one, I think I can answer this as well. So do you have examples of other equipment manufacturer into OptiInstrument? So yeah, currently we have examples in the example library folder. So from Expo and Regal, so we have extensively tested some of the instruments from these two manufacturers, and we've included examples into our sample library. And then obviously, as Ahmed mentioned, we're looking for more manufacturers to come on board and actually collaborate with us. But Ahmed can maybe expand on that if he wants.
Yeah, as we mentioned earlier for another question, like about Keysight, we tested them. We are looking into the data sheets of different vendors, and we're trying to communicate with them to be able to add them into our library. So that's something which we are continuing working on it.
Okay, thank you. So another question here from Zachary Hook. So is it possible to update OptiInstrument's Python installation without updating OptiInstrument itself?
Can you repeat the first part of it again?
Sure. So is it possible to update OptiInstrument's Python installation without updating OptiInstrument itself?
Yeah, so the Python part is actually what we have right now. We created the Python environment within OptiInstrument actually software. So once you download the OptiInstrument, the version of Python is already kind of frozen here. However, you can update your own, and then you can run OptiInstrument externally from the PowerShell or the Windows. So you can have your own update definitely outside. But what we try to do is, because Python is always evolving, and when we created the software, there might be some changes in some commands, and to avoid that problem, we kind of have embedded the Python software within the installation. However, again, you can do that externally with your version and run OptiInstrument from the command prompt.
So yeah, just to add on that, so if you have a Python installation, you can obviously update it separately from PIP from your command prompt as well. So if you just wanted to update the Python library, you can do that separately without affecting OptiInstrument. So yeah, that can be done. So this question was more related to our other offering, OptiSystem, so I wanted to leave it to last. So someone's asking, is there a way or a component to split an optical signal into more than two components, other than polarization beam splitter, which only splits into two components?
Okay, so this is done in OptiSystem. I think the question is related to OptiSystem, not OptiInstrument.
Yeah, exactly.
Yeah, in OptiSystem there is a component called fork, actually, where you can split the signal at the input into two signals, or you can use also 1/n splitter as well. So there is you can do this search find component. So you can put your mouse in the component library, and then you can search for this component like a splitter or a fork, and then you can find the location of that component in the library.
Okay, thank you.
Okay.
So I think those all of the questions that were asked. If anyone else has questions, go ahead and ask them. We still have a couple of minutes that we can answer them.
Thanks, JD.
Yep.
Anyway, so in this slide, as you see here, as we have, you have my email address and you have the support email address, where you can send your questions and inquiries, and we always replies and provide feedback to any question customers, prospects are asking. So I think it's with this we can conclude the webinar, and thank you very much for listening and attending the show. And it's actually here. Thank you.
Yeah, thank you, Ahmed, and thank you, Jaydeep, for presenting today. And thank you for a fantastic presentation. And just a friendly reminder to the audience, if you have any questions or any concerns or anything that came from this presentation you'd like to follow up with Optiwave, Ahmed's email and the support email are both up on the screen. I definitely recommend reaching out to them directly. This webinar was recorded. You will receive an email on Monday with a link to the recording. I also shared it earlier in the webinar in case that's helpful for you guys to be able to rewatch this or pass it along to a colleague. And then with that, I appreciate you all for joining. Just a final reminder, you will see a survey link that will pop up on your screen after you log off of the webinar here. So please be sure to provide your feedback and share that with us. And I hope to see you guys at the next webinar.
Thank you very much.
Yeah,
Thank
thank
you.
you, Sakshi.